Okay, back with another example. This one's a little bit more work, but it's that same idea. You see here we have a little more extensive of a function. We're looking to take the antiderivative of x times the cosine of 2x squared. So we've got a couple things going on here. We're taking the cosine of something pretty ugly, and then we've also got a product happening here. So we're thinking, is this x going to right up here? Is it going to screw things up? And we're going to see that in fact it actually won't make things all that bad. Our first step here, let's identify what u should be. Okay, so think about our basic antiderivative rules. What would we like to see here instead of the cosine of 2x squared? It would be great if we could just see cosine of u, because cosine of u would work just like cosine of x, and that's a nice basic antiderivative that we can take. So let's see if we can do that. Let's make u equal to the extension of cosine. Let's make u equal to 2x squared. All right, so if u is equal to 2x squared, right? Well, now when we start to rewrite our antiderivative, we're going to have the cosine of u, which is good for us, okay? Because that is a nice, easy antiderivative. Cosine of u will antiderive to the sine of u. Yay, we like that, okay? But again, we cannot have a dx in there because u's and x's, they don't go together, all right? So we have to not only pick our u, but we then have to find du, all right? So let's do that. What's the derivative of 2x squared? Again, not all that bad. You guys are experts at deriving at this point. The derivative of 2x squared is 4x dx. Okay, we need that dx right there because now we have to start playing the matching game. All right, du will come into our integrand as long as 4x dx subs out of the integrand. Okay, well, what do we have in our original? Well, we've got the dx, that matches up, and we've got the x, that matches up as well. Right? What we're missing is the 4. So the question is, are we in trouble? And the answer is no, we're not. Okay? If all we're missing is a coefficient, no big deal, because we have our multiplicative identity. And the multiplicative identity says that we can multiply at any time by 1. And you're saying, well, wait a minute, we don't want to multiply by 1, we want to multiply by 4. So let's multiply by 4. Actually, I'm going to change colors here. We're going to multiply by 4. All right, there we go. We multiply by 4. Now we have our 4x dx. Okay, but again, we're not allowed to multiply by 4. We're only allowed to multiply by 1. So we have to multiply by a creative version of 1. So we have 4 here, but we need it to be 1. So what do? Well, we also have to multiply, where am I going to sneak it in right here, by 1/4, right? Because if we multiply this by 4 and by 1/4, then we have technically multiplied by 1. Okay. But we have a small issue here in that we only want 4x dx. All right, du is only coming in if 4x dx is in our integrand. And we've also got this 1/4. All right, du doesn't want that there. So what do we do with it? Well, we just move it just a little bit because ultimately 1/4, just like 4, is a coefficient. And one of our integral properties is that if we have a coefficient on the inside, where can we move it? Exactly, we can slide it to the outside. So this 1/4 is actually going to come and move right over on the outside. All right, so we no longer have it here, we now have it out front. Why is this so good for us? Because, again, it doesn't matter if the quarter's on the inside, outside, or the inside, it's doing the same thing. So in green here, I have a 1. I have 1/4 times 4. That's 1. So I've multiplied by 1, which means I have not upset the balance of my function here, but yet I've got the 4 where I need it, so now I have 4x dx. 4x dx, they're going to combine, and they're going to sub out, and du is going to sub in. All right, so I'm going to have du right here. Okay? Now, the key thing to remember, though, is that this 1/4 did not sub out. It's still around. It's hanging around, and in fact, still hanging around right out front there. Okay, so I've done my u substitution, but in order to do my u substitution, I needed to bring in this 4, and I needed to bring in this 1/4. The 4 subbed out, so it's gone, but the 1/4 is still hanging around, and in fact, the 1/4 is going to be part of our answer. Let's do our antiderivative now. We can do it because of a nice, easy antiderivative to take. The antiderivative of cosine is sine, exactly. So here we go. We have the 1/4, which is still part of our answer. All right, so 1/4. Cosine's antiderivative is sine, so we have the sine of u plus c. Okay, and again, that's a nice, easy antiderivative to take. We were allowed to do it because we just had one single variable right there, instead of an expression that's more than a variable. Okay, we don't want our answer in terms of u, we want our answer in terms of x. We know that u is equal to 2x squared, so we have 1/4 sine 2x squared plus c. Okay, that's going to be our answer. And we know it's our answer, and that is correct because, once again, we can always check our answer. Let's say that this is our function. All right, let's take the derivative of this. Well, if we were to take the derivative of this, the 1/4 is a coefficient, so we would move down. All right, what's the derivative of sine? Cosine. So we have the sine of ugly, so that becomes the cosine of ugly. All right, using our chain rule, though, if we have the sine of ugly, yes, we have the cosine of ugly in the derivative, but we then have to multiply by the derivative of the ugly part, the derivative of the inner function. The inner function is 2x squared. The derivative of 2x squared is 4x. And then the derivative of plus c, as always, is just going to go to 0. Now, let's take a look at this answer. We have a 4 and a 1/4, so they wipe each other out. And we're left with x cosine 2x squared, which is exactly what we originally had up here before we wrote in the 4 and the quarter. So it checks out, which means our answer is correct. Okay? So that means that if we're missing a coefficient, no big deal, we can still get our answer. And I'll do another one like this in the next example.